My name is Aengus Rooney. I am with Grafana Labs. I'm on the solutions engineering team here, at Grafana Labs. I'm joined here by my colleagues, Vili and Katie. We'll be around for a little bit afterwards. So if you want to come and talk to us, give us a shout. We're also going for beer. If anybody wants to have a beer with us, happy to buy a few beers after the conference. Somewhere local here. Okay, so this is a real challenge I've been given to see how we can get from zero visibility to full observability in less than 30 minutes. I'm going to be using, obviously, the Grafana stack, Grafana Cloud, but it can be done with all the open source. The Grafana Cloud bundles all the open source as a service, obviously. So everything you see and do here, you can do either on Grafana Cloud with a free account, or you can do with all the open source products that we provide. It's going to be a bit of a rush. Hopefully going to get to the end of it. I'm going to jump straight in. So what we're going to cover is, I'm going to give you a few slides just on the high-level architecture, what we're going to be looking at. We're going to use what's called the Kubernetes integration in Grafana Cloud. That's going to deploy the Grafana agent that will send metrics, logs, and traces from a Kubernetes cluster up to Grafana Cloud, Prometheus, Loki, and Tempo, which are the storage and search engines for your aggregated metrics, logs, and traces. We're going to visualize it all in Grafana, obviously. We're going to, once we're ingesting data, we're going from the Kubernetes cluster, we're going to go back and look at the out-of-the-box dashboards and alerts for those metrics, logs, and traces. And then, we're going to do some exploration and look at the portal. And then finally, we're going to look at an application running. And we're going to look at how we can correlate events in metrics with the logs for that application, with the trace for that application as well. And if we have time, we're going to have a quick look at everything we're going to be doing is through the UI. But if you want to replicate this, you can do it through the UI like I'm doing today, or you can just do it with a script, a shell script, or a Terraform provider. So if we have time, we'll look into that. Otherwise, I'll share some links with you. Okay, and this is going to be a bit difficult because I'm going to have to do typing and hold the microphone at the same time. So at the high level, Grafana provides for observability, obviously Grafana itself. That's where we started off in 2014. Our co-founder, Torkel, up in Sweden, he actually forked Kibana. I think most of you know we forked Kibana originally back then. Because with Kibana, you can only use it with Elasticsearch, so it's great at what it does, but great for Elastic, full stop. So Grafana uses a lot of the kind of same visualizations originally as Elastic, but you can plug it into different data sources. We now provide Prometheus, Loki, and Tempo as the aggregation and storage engines for metrics, logs, and traces, but you can bring your own as well. You can bring Influx or Elastic and use plugins for the different metrics, logs, and traces data stores, so like Jaeger for tracing. You don't have to use the technologies that we provide. Grafana Cloud obviously provides this layer here. And very briefly, there's the open source layer. So Grafana Mimir is the again, open source project, but it addresses the limitations of Prometheus. Prometheus is vertically scalable. So when you get to a certain scale of your metrics aggregation, it starts to crash and burn. High cardinality kills it. Mimir is a Prometheus compatible project that allows you to scale Prometheus basically. So once you start getting to the millions, tens of millions, hundreds of millions of metrics, that's where Mimir comes in. That's what we're running in cloud. It's also, you can run it yourself open source. Loki is a log aggregation engine. Grafana Labs ourselves, we were using Elastic ourselves to monitor our own cloud services. We got to a tipping point there as well, so we went and we wrote another log aggregation system. It does a partial indexing of the log labels. That's the key thing to think about. So you don't end up with these massive indexes that you have to maintain the whole time. And Tempo then follows the same architecture I'm going to show you in a second, which is again a scalable, low-cost backend for the aggregation and search of traces, which can be sent to Grafana Cloud or Tempo via your standard open source collectors like Jaeger, Zipkin, OpenTelemetry. Then at the top layer, we have our SaaS equivalents of each. We call them Grafana Cloud Metrics, Logs, and Traces. We do have a enterprise layer as well. So these are obviously open source community support. Grafana Labs provides support for Grafana Enterprise Metrics, Logs, and Traces, which you can download and install, deploy on your own in your own regions or in your own data centers. And we're going to be using top layer today. So this is Grafana Cloud, and Grafana Cloud, this is our core set, as it's saying here, for observability, Grafana for visualization, Prometheus, Loki, and Tempo for metrics, logs, and traces, and then K6 for your shift left performance testing, etc., etc. But we have all these different types of applications on top of obviously the core systems that you can use for machine learning instance on-call Kubernetes integration, which we're using today, synthetic, black box monitoring, etc., etc., etc. Yep, I won't do that right now. Okay, and this is the architecture. It's kind of irrelevant in cloud because we manage all this for you, but the architecture of the stores for metrics, logs, and traces, so for Prometheus/Mimir, Loki, and Tempo is microservices. So we're running the ingesters, the distributors, the queryers as on Kubernetes essentially. So we run Grafana Labs cloud services in GCP, Azure, AWS. Again, it's invisible to you if you're using our services. But essentially, we're running on GKE, AKS, and EKS in the back end. So we can horizontally scale each of these services of those aggregation engines based on the load that's coming into us. So as are all our customers are sending us metrics, logs, and traces, or searching those metrics, logs, and traces, creating dashboards, etc. We're obviously auto-scaling and monitoring the workload coming in and managing all that for you. So even high cardinality now doesn't really impact you as much in cloud. It'll cause performance issues, but it won't crash anything. And what we're going to do now in the next 20 minutes is we're going to use the Grafana agent. So what you can do is you can use Prometheus itself, Prometheus open source, and remote write your metrics to Grafana Cloud. You can use Promtail to ship logs to Grafana Cloud, and you can use OpenTelemetry, Jaeger, Zipkin to ship traces to Grafana Cloud. Where the Grafana agent is essentially bundles up each of those shippers, and you can deploy the agent to ship metrics, logs, and traces using the same protocol. So you'll be using remote write, you'll be using the Promtail, you'll be using OpenTelemetry collector in the Grafana agent. It just makes it easier to deploy on Kubernetes, and it also has some wraparounds. So in terms of the configurations, you can start to inherit some of the Kubernetes metadata and automatically apply those labels to your data, to your logs, to your metrics, etc., etc. Okay, so that's what we're going to do. We're going to do I've already spun up a Kubernetes cluster. I have already spun up a Grafana Cloud account, and we're going to use the integration to deploy the agent and scrape some metrics, logs, and traces from the Kubernetes cluster and ship to cloud, and then we're going to go and visualize them with the out-of-the-box dashboards. And finally, the last slide is what we're trying to achieve, or what we're trying to provide, or what we do provide is the ability to be able to correlate your metrics, logs, and traces. So by using common labels, and that's the beauty of Tempo and Loki is based on the same data model as Prometheus. So you can apply labels on ingest and use that label as the key to correlate between metrics, logs, and traces. So if you say in your PromQL query, give me metrics for pod equal to ABC, you can do the same with logs. You can say, give me logs for label pod equal to ABC, and likewise for traces. So then that key carries across metrics, logs, and traces, and at the very end, I'll show you how that applies in the dashboards, how you can very easily pull up the logs for an application where you're from looking at metrics from an application, pull up the logs very quickly and easily using the same key. And at the end, there's a survey. I don't know if you can take a picture of that there. If not, come up to me afterwards and take a picture. Feedback. If you're at the workshop earlier today, I'm not sure, a few faces here that were. We can feedback on the workshop or any of the content today as well. And we can also send you links and stuff for what you're seeing today. And you can win a Grafana t-shirt. Okay. So I'm running on Kubernetes in GKE in GCP. This is my source data, so to speak. It's kind of irrelevant. Any of the standard releases of Kubernetes will work with the Grafana agent. I have pre-provisioned my Grafana Cloud account, and if you want to provision a Grafana Cloud account, Grafana Cloud will provision if you go to grafana.com, front page, I think there's a link there to say sign up for a free account. The free account is free forever. You just need to put in your email address. It is limited to one user and 50 gigs of logs per day, 1,500 active series metrics per day. But it's a nice place to go test stuff. And it also gives you a Grafana endpoint, a Prometheus endpoint to send your metrics, a Loki endpoint to send your logs. There's also a Graphite endpoint there. Is kind of we worked on Graphite before Prometheus became the dominant metrics engine, I guess. And then a tempo endpoint and an alert manager as well. So by adding an email address, you can spin up your own account and you can copy everything we're doing here today. Okay, so if I go in then and I launch my Grafana instance, bear in mind this is a fresh Kubernetes cluster. We'll see when we see the metrics. I spun this up at around midday today. Again, with this Grafana account, it's completely new, so there's no data in there yet, so we're going to start ingesting some data. So in here, you can see in Grafana, if I go and browse, we have no dashboards yet. Well, there's a couple of the out-of-the-box dashboards, like the home dashboard and the Grafana Cloud meta monitoring dashboards, but we've no Kubernetes dashboards yet. And if I go to look at the data, I can see in my Prometheus, for example, there is nothing been found yet, so I have no data in there yet. So let's go and connect to our Kubernetes cluster, deploy the agent, and get some data in. If I go scroll down here a little bit to, how do I go full screen? Here we go. No, why doesn't that go to? Okay. If I go down here to this little icon here in Grafana Cloud, integrations and connections. Again, this is out of the box in cloud, but you can build what we've built in cloud with the open source as well. You go to integrations, and if you look for Kubernetes, which isn't too far down, Kubernetes monitoring. This is like a quick start to help you deploy what we call the Kubernetes integration. And it's essentially going to help you to deploy the agent, the config map that will ingest the metrics, logs, and traces. So click on Start Sending Data. We're going to use the Grafana agent, yes. We're going to install some dashboards and rules, and then we're going to go and install the agent and deploy a config map for the agent. I'm going to click on this button. That is, at the moment, just going to download and install some dashboards and alert rules. So like a kind of canned set of dashboards and alerts that you can use and build on as your base build on a base set of dashboards and alerts to build out what you want for your monitoring. We'll come back and look at those in a minute. We want to go and get some data in first because the dashboards won't look very interesting without any data in there. So our dashboards have been installed, great, and so for alerts, let's go and configure the agent. This brings you into a couple of command line scripts you're going to have to run. As you can see, there are some prereqs. You're going to need to have kube control, access to kube control, and you will have to be able to run Helm, etc., etc. There's 2 or 3 steps in here. What we're going to do first is deploy the agent and config map to collect metrics. We're going to do these now in a minute. Just telling you in advance what they are. We're going to use Helm to deploy kubesec metrics on the Kubernetes cluster, so we get all the KSM metrics, obviously. And we're going to deploy the agent and daemon set for config map for logs also. I think I need to switch my context. So we're going to start here at the events. And again, because you probably can't read that, what we're saying here is, the default scrape interval is 1 minute for cost reasons in cloud. You can just copy and paste this command here, and that will deploy the config map, change your namespace if you want, and this will then start collecting CVisor, kubelet, and kubesec metrics. I'll show you that config map in a bit more detail. And once you have the config map deployed, you just then need to run the Grafana agent as a stateful set. The stateful set the agent will pick up the config map and start scraping all the metrics and logs from the cluster and shipping them to cloud. So I'm going to. Can you hear me at the back if I don't use the mic?
I want to keep recording the audio.
Oh, you're recording. Okay. Bear with me, if you wouldn't mind. Yeah. Thank you. Okay, I need to switch context first of all. So I'm going to go back here and check out this guy that I spun up earlier. and get my connection details. There we go. Okay, copy that. Go down to my terminal. I'm going to start a new terminal. Okay, so I'm going to connect to that Kubernetes cluster that we're using. And while that's connecting, I'm going to go back in and I'm going to copy one of these commands. So back in here. Looking at the metrics and events, I'm going to copy that config map. And let me just show you very quickly what's happening in this config map. Syntax YAML. So this is deploying the agent, and in here you can see, sorry, it's deploying the config map for the agent. And you can see in here, if people are familiar with Prometheus, we have a scrape config where we're going to operate with the Kubernetes Service Discovery API and pull in all the metrics from kubestate metrics, CAdvisor, etc. And we're going to inherit all the labels from Kubernetes metadata, drop some, keep some, and modify some to apply those as labels in Prometheus. So if I go and run that, it's still connecting. Okay, just double check that is okay, yeah. So run it as so, copy and paste, that's going to kube control apply that config map. Okay, config map created, go back to my cheat sheet here. I've done the config map, now go down to the agent stateful set, I'll copy that. That's essentially just a shell command that's going to pull down the agent config, it runs as a service, and let me take a quick look at that actually as well to explain it. So yeah, define a cluster role binding, create the service, stateful set, and then run the agent, the Grafana agent that will pick up the config map and start sending all those metrics. So again, I just need to copy that, go back and kube control apply that. Now we've created the Grafana agent, the cluster role, the role binding, etc., etc. So that's all running. Hopefully, 0.1 almost running. Container creating. Okay, while that's creating, we're going to go back here and we're going to apply the Helm chart for the kubestate metrics. So if I copy that Helm chart will just go and install kubestate metrics, which is a daemon that's going to run to collect all the metrics from the kubelets and provide those metrics at a Prometheus endpoint, which the agent's going to scrape and send to Grafana Cloud. Okay. Okay, almost there. Okay, there we go. Now if I go back to my Grafana, we've done all these steps. There's another, in the first step, we're also collecting a certain amount of logs. There's a second step there to collect more verbose logs from more services. I'm not going to do that in the interest of time. I'm going to close there, and I'm going to say at the moment that we are going to finish our configuration. Go back into the main space. First of all, before we go back into the portal dashboards here, we're going to go and explore the data because I should now see in my Prometheus, my Grafana Cloud Prometheus is metrics coming in here. Yeah, so I can go and say, start searching for cube state, whatever, operations total. So what I'm doing is I'm using the explore function to browse for a metric. I'm going to pick a label for that metric. I'm going to pick the label value, and then I'm going to say use the query to show me the metrics. So that is, yeah, displaying the Okay, let me look at the time. 1 hour, 15 minutes. That might be a bit better. Okay, we start to see metrics coming in there. What I can also do is I can, let me find a better metric to use. Container metric maybe. Usage seconds. I'm going to use the cluster label, value of cloud, use that query. Okay, so we can see some metrics coming in there and their values. What I want to see also is the logs related to this label cluster. So if I split my screen, on the right hand side, it's going to pull up a second screen also with the Prometheus data source. I'm going to change the data source from Prometheus to Loki, and in here, Grafana picks up the label of cluster equal to cloud, applies it to my query on the right hand side, which is now Loki, and then starts to pull back all the logs for that cluster. So very, very quickly, I've got by deploying the agent in the config map, I've got some metrics and logs coming in from Kubernetes. We can go back to the Kubernetes monitoring view or portal, and we've done all that. We can go to dashboards here, and we can see there's a number of dashboards out of the box that are provided. So if I go in and take a look at the compute resources / cluster, for example, we can see here the metrics out of the box dashboards that are visualizing the metrics for you already. And if I go back there again, I can take a look at the alerts. So we've also, aside from the dashboards, we've created a set of alerts, and we've got everything's normal, which is good. So I can go in here and take a look at the alerts, or I can go into the alerting framework and take a look in detail at those alert rules. So I might be interested in using these alert rules as is, or I might want to edit them. So the node namespace node, recording rules. Here's some alerts. QPod crash looping, I can use it as is, or I can go in and I can edit the promql that's in use for the alert at this point, edit to suit my own purposes, etc., etc. Okay, so we now have everything we need in terms of, so far from system metrics and logs from Kubernetes. As applications that get deployed, because the agent is working with the Kubernetes Service Discovery API, as pods get spun up for applications, the agent will start to notice, register, and scrape metrics for that application as well. And then what you can do is you can tie everything together and start to correlate your data by doing something like this. I'm going to cheat and open another dashboard that I already created. So in here, what we're looking at is a metrics dashboard for a 3-tier service. We've got requests coming in across the load balancer, hitting the application server, and the application server works with the database in the back end. And what we're doing, this is a red dashboard, so we're looking at the rate, error, and duration of the requests as they come in to the service. We're looking at the queries per second and the latency of responses at the load balancer level, the application level, and the database level. What we're seeing is some 500s building up in our metrics, and we want to go and take a look at the logs and the traces maybe for this. So we go and we will maybe explore this query first of all. We can see it's the 500s that were the red lines that are increasing. What we're looking at is, TNS is just the name of the application. We're looking at the request duration seconds count metric for the TNS application, for all applications being scraped by the job equal to XYZ. And we're summing the status code, so also we see the 400s, 500s, 200s, etc., etc. So we know something's happening to our service, but we don't know what's happening yet. What we want to do is, again, split our dashboard, bring in our logs. Again, just pull up our Loki data source. And again, Grafana will pick up the label at this point, which this time is the job equal to regex .app. Apply that, pull up the logs, and in here then we can go and search for some errors using filter expressions like error. I'm going to look a bit more specifically for the status equal to 500. Refresh that. And then I'll see I would go in, I'd browse my logs, I'd start to take a look at some of the error messages I'm seeing. But I'd also, from this point, maybe if I go back to the full view of the application logs, I can also see that I have traces being embedded in my log lines. So in here, this trace ID, we're using OpenTelemetry to generate the traces for this application, and we're writing those to tempo. I'm linking between my, the OpenTelemetry is also writing the trace ID to my logs, and I can use this linking between Loki and Tempo to bring me straight from the log line to the trace for the service. So in here you can see again, let me close the left-hand side, I've got the three-tier application, or a view of the request coming in across the three-tier application, where it's hitting the load balancer, the application server, and the database, and then I can drill into what's happening, where it's happening, the database calls, the database statements, the HTTP statements, etc., and down to which level it's happening on, which pod it's happening on. And I can even go back to the logs for a particular span to go and browse those logs in a bit more detail. So that's, at a high level, I think, is everything I was going to show you today. Did I cover everything in the agenda? Or did I forget anything? Oh yeah, the last thing was just to share a shell script or a Terraform provider. If you want to, everything I did there in the UI can be automated, obviously. If you take a look at my GitHub, there is this guy here. This Grafana agent Istio, so we're also deploying Istio service mesh on the Grafana cluster, on the Kubernetes cluster with this script. And the reason we're doing that is to get some out of the box automated tracing through Envoy with Istio. So every service request that comes through Envoy will be automatically traced by the OpenTelemetry injection that we're putting into the cluster, and then we'll get automatic traces for every application as well being served to the backend services. So that's a bash script essentially that walks you through a number of steps that you can use to replicate everything we've seen today. All right, that's it. Thank you very much. Any questions on any of that, or is it all perfectly clear?